Today on How It's Made Dream Cars, the ultralight KTM Crossbow, always road and race ready. As one of the largest European motorcycle manufacturers, KTM is more than all-terrain bikes. Since 1994, the company has manufactured and developed race-ready off-road and street motorcycles. Motorsports has been the main focus of the brand. KTM's racing team has won more than 200 World Championship titles, countless national titles, and 10 Dakar Rally titles. KTM's only car series, the Crossbow, is heavily influenced by the brand's superbikes. With a powerful engine, solid chassis, and beaming presence, the Crossbow is radical in the sports car segment. It debuted in 2008 at the International Geneva Motor Show, with state-of-the-art technology features and a revolutionary design. With the construction elements like carbon fiber, aggressive styling, and unbelievable performance, the Crossbow is KTM's answer to extreme sports on four wheels. The KTM Crossbow is manufactured at a special plant in Graz, Austria. In the concept phase, the designers toyed with various construction methods and specialty parts, including the use of a tubular space frame made from chrome molybdenum steel. The Crossbow is produced in 18 months and relies on many collaborators. Designers use advanced computer software to visualize their ideas in various paint colors and road conditions before production. They then use clay sculptures with functional metal pieces to test their ideas. The Crossbow's compact design leaves a very powerful impression. It delivers an incredible level of driving comfort without sacrificing any racing charm. To produce the fiber-reinforced parts, they place carbon fiber mats into a mold. The cloth mats are chosen based on strength and torsional stiffness properties. The car's two-part 176-pound carbon monocoque is made up of 4 layers infused with epoxy resin. 4 ceiling humidifiers dispense a hydrating mist, keeping the room's moisture level at a consistent level. This ensures good air quality for staff and materials. Workers place pre-cut adhesive sheets of woven carbon fiber to the seating section. This process laminates single carbon fiber layers together. The workers use putty knives to conform the fiber's films and remove air pockets. Additional carbon fiber pieces are added to specific areas to ensure a fine and well-produced overall structure. This process ensures that the car is both very rigid and extremely lightweight. Next, workers place a thick protective covering over the mold. Couplings connected to air suction hoses remove air and apply gravitational pressure, forcing the layers of carbon fiber to shape against the mold. In a pressurized oven, the fibrous material cures at 248 degrees. This forces the mats to release the resin. The monocoque is a 2-part construction. The first part is the base. The second larger part completes the rest of the chassis. The parts are fastened together with a high-strength epoxy resin. An automatic material feeder moves the top portion of the monocoque into a finishing chamber for deflashing, drilling, and processing. While in the finishing chamber, a robot drills holes in the monocoque. The holes are for various components that will be attached later. Aluminum inserts inside the carbon fiber chassis are drilled for the addition of other elements later. At another station, workers add a bonding glue called DP490 to the frame of the windshield. The two-component epoxy adhesive is designed for high strength and environmental resistance. They place the epoxy over as much surface as possible for maximum adhesion. Once the epoxy is evenly distributed, the casing moves to the cockpit shell for assembly. F-clamps secure the structure into position. Bonding takes 4 to 6 hours, drying at about 74 degrees. The car's carbon fiber body panels are made in a series of simple steps, like design, construction, curing, and sanding. Components are painted with a protective primer and finished with a clear coat of paint and decals. The KTM Crossbow's fashionable design is sure to turn heads, especially its rear structural unit. It illustrates their unequivocal passion for racing flair. Next, the steering column assembly. A technician sprays lubricant onto the steering column shaft. He then fits a lightweight non-magnetic spacer over the shaft and inserts it into the adjuster. With the help of lubricant, the technician attaches part of the upper steering shaft by twisting it into position. The universal joint is inserted into the intermediate shaft. It transmits steering data to and from the cockpit and the wheels via an infrared transmitter. The universal joint is secured with a locking washer and screws. Then, the technician installs a plastic column ring containing electrical wiring that relays navigational orders and other functions within the system. He delicately melts the cabling using a handheld heat gun to shrink wrap the rubber cover. He also wraps cloth-based adhesive tape on the outer column. To finalize the adjustable steering column's construction, the technician slides the inner post over top of the outer column. The steering column also provides the mounting for switches and other instruments. Assembling the rear structural unit starts with the mainframe, which includes the license plate holder. The technician slides the muffler cover into pre-existing slits. Hardware is added to secure it in place. The license plate lights are installed in the frame and fastened with screws. Support arms are added as well. The technician attaches each of the uniquely designed tail lights with screws and an impact driver. The taillight wiring system is simple. In the cockpit is a switch. When the driver presses down on the brake pedal, the circuit is complete, triggering the taillights to turn on. The wires are held to the wing's framework with cable ties. Any excess pieces from the ties are removed with cutting pliers. The rear structural unit is finished and ready to join the chassis. Brake assembly begins when a specialist inserts the primary wheel carriers into vices. Next, the coupling of the wheel hub is added. The worker secures it with a torque wrench to meet the vehicle's specifications. Now the brake dust shields are added. They prevent dirt and debris from accumulating in the braking system. One of the most important parts of the brake system is the rotor. It receives a holding bolt for positioning. The worker adjusts the holding jig to a secondary position and installs the calipers. They perform the mechanical aspect of the braking action. Separate calipers are installed for the handbrake on the rear wheel carriers. He ensures that all bolts are precisely adjusted using an electronic measuring wrench controlled by a built-in microprocessor. At another workstation, the technician secures the unfinished brake system into a holding unit. He adds the control arms and locks them in position with an electric torque wrench. The conclusion? Ultimate short-range braking power. Headquartered in Mattighofen, Austria, workers build 80,000 KTM orange motorcycles every year. The company may even be the first to produce an electric off-road bike. But for now, new territory comes with the Crossbow. In this room, the chassis and running parts come together. Using an overhead lift, a technician lowers the monocoque onto a series of assembly jigs. Next, workers glide the rear section of the space frame toward the carbon fiber monocoque, attaching it to the lightweight chassis. This part of the base frame contains the rear suspension and drive shaft units. This part also supports the engine and gearbox assembly units. At another workstation, the turbocharger intercooler is readied. It's used to cool the turbocharger during the semi-adiabatic compression process. The intercooler is attached to the firewall, which provides a safety barrier between the engine and cockpit. Next, the intercooler and firewall are connected to the intercooling pump system. The small Audi engine produces 285 horsepower and accelerates from 0 to 60 in just over 4 seconds. Using an air hoist, the workers lower the fuel-injected power unit and gearbox into the space frame. While most manufacturers mount a car's running gear vertically with the chassis, the Crossbow's components are mounted horizontally. Next, workers attach the racing-inspired pushrod springs and dampers. These ensure the vehicle has optimum contact with the road. Grabbing the right front suspension component by the control arms, a technician bolts the unit into 4 specific inserts within the twin-wall carbon fiber monocoque. Attaching additional parts is quick because holes and body sections are machined in advance. The technician verifies the suspension unit is secure by manually lifting and pulling the unit. Then he installs the pedal assembly. It utilizes 3 lightweight aluminum pedals that control the brake, clutch, and throttle. The pedals are attached to a rail so they can be adjusted to accommodate any driver. Next, the technician connects the electrical wiring of the lightweight aluminum shift console and gear lever guide. These components help deliver short and ultra-precise gear changes. Unlike other sports cars, this vehicle uses an atypical singular multifunction display. The display is similar to the company's superbikes, which deliver operational feedback and trip information. The engine's protective cover goes over the valve components. The remaining engine tubing and piping is connected to the proper ducts after the lid is added. In case of a crash, these protective steel roll bars can withstand loads of up to 2.5 times the car's weight. Now, the rear bumper and lighting systems are securely installed onto the rear space frame. A deep-sounding exhaust is a must for any sports car. This metallic exhaust system is a simplistic silencing block. It adds a distinct look and tone to the vehicle. Workers carefully remove a two-piece aluminum harness. This harness helps move the front windshield and side windows onto the car's main body for installation. The performance wheels are 18 inches in the front and 19 in the rear. Now that the major running components are installed, the car is ready for a road test to guarantee performance. With fine-tuned performance and near limitless vehicle customization, the KTM Crossbow is a genuine sports car of the purest variety. At the filling station, each and every car receives the necessary running fluids required for the vehicle's overall performance. First, the engine coolant. It is designed to remove excess heat from the engine. Other complementary chemicals include premium gasoline and engine oil. The engine oil lubricates various internal parts of the engine. Also, fluids are added for braking, transmission, windshield washing, and power steering. At the next station, a technician adjusts the wheels using an elite alignment system. This system uses high-resolution cameras and optical lasers to provide alignment measurements with pinpoint accuracy. Wheel-mounted sensors with triangular reflectors deliver the information to the camera. The camera transfers that information to the main computer console. This allows the technician to make adjustments as needed for camber, wheel loads, toe set, and steering wheel positioning. This is the first time the engine is cycled. To test its powerful driving dynamics, KTM uses a dynamometer test room. Once the car is on a set of test rollers, a rear security road blocker raises into place, and the trial run begins. During this rolling road test, the software records and analyzes the performance of the motor's power and torque output. The front splitter, main body, and rear diffuser can generate over 400 pounds of downforce at high speeds. The main underfloor and rear diffuser are mounted. Then a carbon exhaust cover is added, offering a protective aesthetic. The crash box offers collision safety, airflow optimization, and reduces understeer. A lighting system, license plate holder, front splitter, and aerodynamic front fins are all attached to the crash box. Workers secure the completed crash box to the rest of the chassis with impact drivers. In a head-on collision, where the car is traveling at speeds of around 40 miles per hour or less, the crash box will absorb the energy of the impact, leaving the monocoque front virtually unharmed. At the final station, carbon fiber body panels are installed to complete the car's sharp outer aesthetic. With its roofless stance and performance posture, the Crossbow is perfect for sunny days and winding roads. But in the case of rain, the crosstop can be mounted. Installation takes less than 5 minutes and never compromises a driver's ability to get in or out of the car. The cover is made of a water and dirt repellent synthetic fabric. It is stored in the passenger footwell. From esteemed motorcycle origins, the Crossbow is a riveting sports car, fusing elements like a super stiff chassis, a turbocharged engine, superb steering and braking power. KTM's Crossbow is made to be driven with bold conviction on any road or track.